Here we go. Brandon, can you see it?
Yeah, I can see it.
All right, here we go.
Get ready for some third.
From galaxies and stars down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these and many other numbers have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are 3 live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect, a vast, spectacularly complex, highly ordered universe inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common sense interpretation of the facts suggests that a super intellect monkeyed with physics and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
All right. So I want to kind of work our way through the chapter here, and then we'll kind of do what we did before. We'll deal with some objections, but first I want to make sure we are all kind of understanding what this argument is. Okay. So first of all, and on page, did everybody get a chance to read this? That's first of all. If you didn't, I'm not going to call you out. If you didn't, you should. It will help you understand this better. But on page 107 at the bottom there, it talks about two kinds of fine-tuning. And then they have the two kinds here, nature's constant and then arbitrary quantities. All right. So I think to understand this argument, you really have to get a grasp on what they're talking about. The constants of nature would be, for example, like the gravitational constant that they talked about there. Like, so it just happens to be that particular number. So again, why, like, that's one of the questions. Why is it that number? Does it have to be that number? And according to what we just watched in the video, does it have to be that number? No. So again, like after a while, you're like, well, that's weird because it just happens to be the exactly right number to 10 to the 60th degrees to be the one that's life permitting, right? So if it was just one of those things, you'd be like, oh, okay. But then after you start, like, well, there's another one, and there's another one, and there's another one. You're like, what's going on here, right? It'd be like if I started, flipping a quarter and it just kept coming up heads all the time. You're like, after a while, you're like, something's wrong. You've rigged this somehow, right? So you have the constants. Okay, and so he talks about the force of gravity, the electromagnetic force, the subatomic weak force, and stuff like that. And then you have the quantities. And so the quantities, he says, are the way, like, it's like the initial conditions that are kind of built into the beginning of the universe, right? So he gives an example of the amount of thermodynamic disorder or entropy in the early universe, right? So we talked about the second law of thermodynamics, how the universe is running out of usable energy. But it just so happens that, like, the way, like, when the universe started, it has all this usable energy that's there, right? So, like, there's these built-in quantities that are, like, there at the beginning. But, like, who determined that? And I'm going to show you another video where they'll talk about, like, even when the physicists try to do these equations to these things, they have to put in these quantities to even be able to come up with an answer. And so, again, it's that problem of design, right? Like, you can't even get an answer if you don't put these equations. And so who put the initial parameters on this? Because again, nature doesn't do that, right? It points to an intelligence. It points to someone, a person must have entered these constants into this situation. And they all happen to be just the right constants for us to be here, okay? So that's the idea of this fine tuning, he goes on to say. He says that these constants and quantities must fall into an extraordinarily narrow range of values for the universe to be life permitting. And then they go on to give you all the examples, and some of those he talked about in the video. So I'll leave that to you to read if you haven't read it already. But then on page 110, they start talking about the objections to this. And so sometimes you'll find people say things like this. He says, but if the constants and quantities had different values, then maybe different forms of life might have evolved. But again, just from what you saw, and if you read this, how would you answer that? You say, well, it might not be like us, but that doesn't mean that there wouldn't be life in the universe. So you can't say that it was designed, because life still might have arisen in the universe. So what would the answer to that be?
Well then, how about like how fine-tuned would it have to be for that life to exist?
Look at it. The answer's there. And they said there on the thing. Remember at the beginning?
When scientists say universe is life permitting, they're not talking about just present forms of life. By life, scientists just mean the property of organisms to take in food, extract energy from it, grow, adapt to their environment, and reproduce.
Right. So just based on what he said, remember there would be no
Stars.
or
Planets.
or
Life.
Or life.
or even chemistry.
Yeah.
Right? So it's not a matter of like, well, we're going to get some different form of life. We don't even have chemistry. So how could you get life if you don't even have the different chemical compounds that make up life, right? Then he gives another objection here. He says, maybe in a universe governed by different laws of nature, it would be different. But like, can we even figure that out? No, we have to work by the laws that we have in this universe, right? So like, to posit that, you're just like, throwing, like throwing a stone in the ocean, trying to come up with anything. But he says we're not concerned with universes governed by different laws of nature. We have no idea what such universes might be like. Rather, we're concerned solely with universes governed by the same laws of nature, but with different values. So if we take those values and change them in any way, what do we know? The whole thing falls apart. Which screams out for an answer. So that's when you get this argument that he presented in the video. Now, does it have to be that way? That's page 112. Does it have to be that way? And he talks about how in the second paragraph there that people are trying to find this theory of everything. Oftentimes they're trying to use the M theory. It's a type of string theory to come up with this theory of everything. But again, like he says, it permits a vast range of about 10 to the 500 different possible universes, all consistent with the same laws, but varying in the values and constants of nature. Almost all of these possible universes are life prohibiting. So even if you change it, it doesn't get rid of the problem that overwhelmingly the tendency is towards life prohibiting universes, not life permitting universes. So again, it's just as a number of, by a means of probability, you have to say like, what is going on here? Then they say, well, maybe we just got lucky, right? And they talk about the chance thing. And I think the idea of this lottery illustration, did you guys read that? Like that's like, there's all kinds of mistakes when people try to explain this sort of thing. They'll say like, for example, if you think about the lottery, when there's like the Powerball jackpot, and they'll be on the news and they're like, the Powerball's up to $70 billion or whatever. And so everybody buys the ticket and they think, oh, maybe it'll be me, because somebody has to win. That's the point. Somebody has to win. And so like you say, well, what are the odds of winning if 30 million people bought lottery tickets? Sometimes they don't even, like, no one got the right number. So let's say if you figure out, because you can figure out the probability, right? If there's 20 balls and they all have 20 numbers, right? You just multiply it out and you get the probability of whatever. And so you say, well, the probability might be 1 in a billion that you win the lottery, but somebody won. And so they'll say the same thing about the universe. Well, the probability of getting a life permitting universe might be 1 in a billion, but here we are. So we won the cosmic lottery. But as he explains in the situation, I only ask you, what's wrong with that kind of way of thinking? Did you get a chance to read this?
I think it's kind of like, well, it's not exactly talking about like a life permitting universe. It's talking about like, or it's not talking about our universe. It's talking about the chances of a life permitting universe, not just
any universe.
Yeah, not just any.
Right. So it's not that you would just get any universe out of the thing. So he talks about if you put the balls in the pin in the big roller thing, and he says the correct analogy would be a lottery with billions and billions of white ping pong balls were mixed together with just one black ping pong ball. And you're told that one ball will be randomly selected out of the horde. If it's black, you'll be allowed to live. If it's white, you'll be shot. Right? Now, and all of a sudden, the black ball comes out. What are the odds?
1 in
1 billions of billions.
Yeah. So it says it's not that any particular ball would be randomly selected. That's how the lottery thing would work, right? Somebody's got to win, so somebody might have that particular number to just get selected. We need a specific number. That's the difference, right? That this is the only number that will win, and it's not that it's just like some random number that's picked. It's like you know that number before the lottery even happens. Like if it's not this number, so you could pick you could pick a billion different random numbers, but what are the odds that you'll get that number? That's the difference. Does that make sense? So to say that is not correct. The other example that they give here is this. See the picture with the guy in the shooting firing squad here.
Oh.
So he's saying, imagine you're traveling abroad and arrested on trumped up drug charges. You're dragged in front of a firing squad of 100 trained marksmen, and standing at point blank range, you hear the command given, ready, aim, fire. You hear the deafening sound of the guns, and then you observe that you're still alive, that all of the 100 marksmen missed. Now, what would you conclude? Well, I guess I shouldn't be surprised that they all missed. After all, if they hadn't missed, I wouldn't be here to be surprised about it. Nothing more to be explained here. And that's what people say. Like there's an analogy sometimes you'll see on the internet called the puddle analogy. And they'll say like, it's like a puddle that looks at the situation and says, wow, this hole in the ground is exactly right for me to be here. It's just the right shape for me to exist. Like the puddle fits the hole. And so it must be designed. And so they're saying like, no, it's not designed. It's just that's the puddle and that's the hole and they just happen to fill and there's nothing more to know about it. And oftentimes this is called the anthropic principle. Does he talk about that in here? The weak, I don't know if he even has it in here. The weak anthropic principle.
I think he does towards the end.
It says that we can observe only properties of the universe that are compatible with our existence.
What page are you on?
Like 116, I think. I don't know if that's the exact definition, though.
Oh, yeah, it's right above the firing squad. Yeah. So the anthropic principle says that we can observe only properties of the universe that are compatible with our existence. So it's like we shouldn't be surprised that we're in a life permitting universe, because if we weren't in a life permitting universe, we wouldn't be here. So there's nothing to see, nothing to be surprised about. But that's why he had this illustration. It's like, it's not just that we're here, it's that compared to the chances of being in a life prohibiting universe, the fact that we are here cries out for an explanation, because it's overwhelmingly more probable that the firing squad should have shot me than I'm standing there with a line of bullets all around me and no one hit me, right? That's the point of this whole argument. Does that make sense? Like, how do you explain the fact that we shouldn't be here, but we are? And the interesting thing I think that kind of underlies all this stuff is, and I kind of said this before, the idea that a lot of people have is that somehow science is like, so here's all the things that people used to say, well, God explains this. This is the answer, like God is the answer for this. And so the idea that people say today is that science is shrinking the area for God to be, right? Because we can explain all these things away. We don't need to have God as an explanation of these things. But I would actually say that if you that might be true at a superficial level, but if you dig into it, actually I would say that the problems are getting bigger and bigger, right? Because, for example, all the stuff that we're talking about here, these cosmological issues of the fine tuning of the universe, no one knew these 200 years ago. These are all things that have just been discovered in the 20th century. And so the idea before was that, well, the universe is just here and that's easy to explain and nothing more to see. But now, like, you see, okay, like, and this connects to all those other arguments that we had, that the universe is not eternal in the past, that it had a beginning. And then you start to see, like, wait a minute, not just did it have a beginning, but there's all these things that have to be just right, or the universe wouldn't be life permitting. And so then you start piling up probability on probability. And that's what I said last week. So then it's like, okay, here's to get a universe that can even have life at any level. So like you said, you have to have the right thermodynamic set up so that there's usable energy. And then you have to have like star formation in the right way, because, and I'll show you a video that talks about how carbon's formed. So we're all made of carbon, right? We're carbon-based life forms. So if you didn't have that sort of stuff, you wouldn't even have a planet like Earth. And then you pile onto that all the things that have to be possible for a life-permitting planet. And then how do you go from non-living to living, right? How does that happen? Again, there's a great video. I'm not going to take the time to show it in class, but there's a guy named James Tour. Maybe I should show some of it at some point. But he's a synthetic chemist, and he has some great videos on the internet where he talks about how difficult it is to go from non-living to living in terms of biology. And again, like in Darwin's time, they thought that this was not a big deal. Like he thought that an amoeba was just a simple little organism. And it's like now all of a sudden we know, like, wait a minute, there's a lot going on there, right? Little machines that do things, and they're all, all kind of programmed, and you have the DNA and all this sort of stuff. And it's like, how do you explain that? So it's not that like, oh, we figured it all out and problem solved and there's no room for God. It's quite the contrary. It's like these things are so complicated, and the only thing that produces things that are complicated like that have information in them that we know of is what?
A designer.
A designer, a mind, a person, right? So all these things are, so it's not, again, I just want to stress this. It's not like we're just God of the gaps is what it's often called. Like we don't have an answer, so therefore God. Like that's not at all the position that we're taking. The position that we're taking is that these things are all evidences that lead us to a conclusion based on what we uniformly observe in the world that we live in, right? That if I find something, like, think about it. If I walk down the beach and I see like something scribbled in like, I love you on the sand, immediately I assume that there's somebody, like a person that wrote that, right? So like, it's immediate. I don't even think about it, like obvious, like, so it's like if we got up to the moon and we went around the backside of the moon and it said, hey, Josh, you know what I mean? Like somebody wrote that, like, but we see all these things embedded into the natural world. And it's like, how did this get to be like that, right? Like, where did the code come? Where did the information come? Why are these constants the right way? Like all these things are like pointing in the direction. And that's what we see again, just to go back in Romans 1, which you read at the beginning of this whole journey that we're on here. He says in verse 19, because that which is known about God is evident within them, for God made it evident to them. For since the creation of the world, his invisible attributes, his eternal power, and the divine nature have been clearly seen, being understood through what has been made, so that they are without excuse. So God has given an evidence of himself in creation, right? All right. You guys with me so far?
So, like the Big Bang, they say the Big Bang happened from a singularity, but then they say, what about chance? Then they compare it to, and then we say like, that's almost improbable, right? So like, but then they say like, do you know what I'm saying? Like, Like, but then there is the chance, right, that it could happen.
There is,
Like
but
that, I'm just saying from an atheist's point of view.
right. But did you see like what the chance is? Like he says on page 109, the fine tuning here is beyond comprehension. He said having an accuracy of even 1 part out of 10 to the 60 is like firing a bullet toward the other side of the observable universe, 20 billion light years away, and nailing a 1-inch target. And that's just 10 to the 60. But remember, that's 10 to the 60 is just the gravitational constant. You have to multiply that by the other constants too. So it's like, it gets to the point, and that's why they had it on the thing, that they're like, did we get really, really, really lucky? It's like, the numbers here are so...
That was me, sorry.
Oh, what is going on here? The numbers here are so beyond anything that, you know what I mean? And that's again why this analogy of the firing squad. We shouldn't be here, is what it comes down to, right? Like, by any naturalistic explanation, there's no reason to think that we should be here, because these things don't have to be that way, and it's overwhelmingly more likely that they wouldn't be that way. And that's why they showed that thing of all those things balanced, because it's not just one factor. It's all like, I think I saw, like, just for life to exist on the earth, there's over, I think it's like 200 different factors that have to be just right. So that's just that. But then, like, again, we're multiplying that by how do you get life, and then we're multiplying all that by the universe being just right, and so on and so on, right? Does that make sense? All right. I'll show you another video. This is a guy named Stephen Meyer, who is brilliant. Very nice, too. Maybe. I think we can squeeze this in. It's a little bit long, but they tend to go over time upstairs. So.
That is 20 minutes.
We'll speed it up here a little bit.
Well, the fine tuning of the laws and the constants of physics and the initial conditions, that is the arrangement of matter at the beginning of the universe, is one of the most extraordinary discoveries of the 20th century in physics. It started in the 1950s with a man named
There you go. This keyboard is not cool.
was apparent to Hoyle, and the laws and the constants of physics and the initial conditions, that is the arrangement of matter at the beginning of the universe. It's one of the most extraordinary discoveries of the 20th century in physics. It started in the 1950s with a man named Fred Hoyle, a prominent British astrophysicist, now Sir Fred Hoyle. And Hoyle discovered that the conditions that were necessary to make it possible for carbon to form in the universe were incredibly improbable, and there were many conditions that had to combine to make it possible for lighter elements, in particular beryllium and helium, to combine to make carbon. It also was apparent to Hoyle and many other scientists that we need carbon, because carbon is a molecule that allows long chain-like molecules to form, and it's necessary for storing information, which is a critical condition for life. All life is carbon-based. People have speculated about life being silicon-based or something else, but Hoyle and other physicists who knew the score knew that that wasn't a serious proposal. And so it absolutely shocked Hoyle when he discovered how many different parameters had to be just as they are in order for carbon to form. Carbon forms in the center of stars through a process known as nuclear synthesis. If the gravitation inside stars is too weak, then the temperature of the star won't get hot enough so that the beryllium and the helium will combine to form carbon, beryllium and helium being lighter elements. If the gravitation is too strong, however, the star will simply burn up before those critical reactions can take place. And that was only one of a whole suite of exquisitely finely tuned conditions that had to be just right. And when they did the mathematics on this, when they calculated how finely tuned these parameters were, they were getting numbers that were 1 in 10 to the big exponential numbers in each case. So it's a kind of a concept like in engineering of tolerances. Things have to be within very narrow bounds in order for things to work. So in order to get a life-friendly universe, we're kind of in what you might call a Goldilocks zone, where multiple parameters, now we know about 36 of these, the expansion rate of the universe, the strength of gravitational attraction, the ratio of fundamental forces like the electromagnetic force and the strong nuclear force. All of these have, the strength of these forces have to be just right to allow for life to exist and building carbon, having stable planets and galaxies. Many, many conditions of life depend on these fine-tuning parameters being just right. And so you can think of it as a Goldilocks universe, not too hot, not too cold, the force is not too strong, not too weak, speed of light not too fast, not too slow, expansion rate of the universe, not too rapid, not too, so things are just right. And this has caused many physicists, Hoyle in particular, to shift their perspective on the big worldview questions. Hoyle was an atheist who resisted the discovery of the Big Bang because he thought it implied a creation event, came up with an alternative theory that was later refuted called the steady state theory, but then after the fine-tuning realized that that there must be some design behind the universe. And he said a common sense interpretation of the data suggests that a super intellect is monkeyed with physics and chemistry to make life possible. So that's what the fine-tuning is about. It's a powerful evidence of design that's come out of physics. The evidence of the exquisite fine-tuning of the laws, the constants, and the initial conditions of the universe have suggested to many physicists that the universe is a setup job, that it was finely tuned because there was a fine-tuner who chose the parameters. Popular alternative explanation for the fine-tuning is the idea of the multiverse. The multiverse acknowledges that the conditions necessary to make life in this universe are incredibly improbable, but it posits the existence of multiple billions of other universes that would, in toto, make the conditions necessary for life likely somewhere. And then there's the additional assertion that, well, we just happen to be in that lucky universe. And so the multiverse tries to expand what are sometimes called the probabilistic resources. If just one universe isn't enough to render the incredible fine-tuning probable, well, then let's posit a whole bunch of others so that at some point the conditions just must have had to have arisen. Now, in order to make that explanation work, multiverse advocates realize that there needs to be some connection between these different universes. If all the other universes out there have no connection to our universe, then whatever happens in those other universes doesn't affect the probabilities in our universe. So in order to portray these multiverses as the kind of outcome of a cosmic lottery, multiverse advocates have realized they needed to posit some kind of universe generating mechanism that would, in a way, provide a common causal connection between all of them. All of the universes have sprung from the same mechanism, and then we can think of our universe as just one of many outcomes of a kind of lottery. Now, and this is where the problem comes in for the multiverse, because it turns out that every mechanism that's been proposed, whether something out of a cosmology called inflationary cosmology or a mechanism from what's called the string theoretic landscape, every mechanism that's been proposed to explain where these new universes come from has itself required prior fine-tuning. Theoretically, you just don't get this great variety of other universes unless there's something fine-tuning the mechanism. So the upshot of this is that the multiverse explains the fine-tuning only by reference to invoking prior unexplained fine-tuning. And so in the end, you're left right where you started. You haven't really explained the fine-tuning that makes life possible in our universe, or for that matter, anywhere else. One alternative explanation for the fine-tuning of the laws and constants and initial conditions of the universe is the idea known as the weak anthropic principle. According to the weak anthropic principle, we shouldn't be surprised to find that we live in a universe that has conditions which are conducive to our existence. After all, we're here. And since we shouldn't be surprised by the discovery that we live in a universe that has conditions that are conducive to our existence, there's nothing to be explained. No surprise, no need for an explanation. Now, the problem with this alternative explanation is that it really fails to reckon with the thing that really does surprise us, and which is really doesn't need explanation, and that is the incredible improbability of the conditions that are necessary for our existence. We shouldn't be surprised to discover that there are conditions that are conducive to our existence, because after all, we're here. But we can be very surprised to discover that those necessary conditions of our existence are so incredibly improbable. Here's an illustration that gets this across. It's from the philosopher of science, John Leslie. Imagine you're standing before a firing squad of trained Nazi marksmen, and they've found that you've been caught in a plot to kill Hitler or something. Anyway, the order comes, ready, aim, fire, and suddenly there's a barrage of bullets, and you are behind your blindfold, but the noise stops, and you discover you're still alive. And then you turn around, take the blindfold off, and there's a pattern of bullets that circumscribes your body, but none of them hit you. Now he says, of course, says Leslie, you should, what should you think in that place? Well, of course, he says, you shouldn't be surprised to find that you live in a universe that's that has conditions that are consistent with your existence. But you should be surprised that you're still alive, because those conditions are so improbable in relation to what you know about the skill of the marksman and how many of them there were firing at you. So the weak anthropic principle doesn't really explain what needs to be explained, which is not just conditions that are consistent with our existence. It needs to explain the improbability of those conditions, and that it fails to do. Another problem with the weak anthropic principle idea is that it confuses a necessary condition with a causal explanation. In particular, our need for a causal explanation of the incredibly finely tuned and improbable conditions that are necessary for our existence. To illustrate, imagine there's a fire in your city, and the insurance company sends out an investigator to find out what caused the fire to occur. The investigator goes out and he sees, well, there's some matches, there's some old gas cans, there's some little sprinkles of extra gas on a lot of charred buildings. But he doesn't really take any note of that. Instead, he comes back, he files his report, and he tells the insurance company, well, I know what caused the building to burn down. It was the oxygen in the atmosphere. They say, what, oxygen? Yes, oxygen, he says, is a necessary condition of fire. You can't have a fire without oxygen. Well, what's his mistake? Well, he's confused a necessary condition with a cause, or a sufficient condition, or a set of sufficient conditions. And really the cause was, in this case, arson, and he overlooked all the clues. Well, this is effectively what the weak anthropic principle does. It says, well, here's we are citing a necessary condition of our existence, all these fine-tuning parameters. What more do we need to explain why we're here? Well, what we really want to know is not just what the conditions are. We want to know, and whether they're necessary or not, we want to know what caused those conditions to come into existence that would explain jointly why life is present. And that the weak anthropic principle doesn't do. What we need to know instead is a causal explanation. Design provides that explanation because it tells you why the conditions were set and why they're so incredibly improbable. The weak anthropic principle doesn't. One of the great discoveries of the 20th century that has challenged materialism as a philosophy at a fundamental level is the discovery that the universe had a definite beginning. In fact, the material universe is now thought to have had a definite beginning. That if you go back far enough in time, the curvature of space becomes infinitely tight, corresponding to zero spatial volume. That's a consequence of a theorem known as the singularity theorem that Stephen Hawking and Roger Penrose proved in 1968. It was a consequence of their solving Einstein's gravitational field equations, reflecting his theory of general relativity. So this is a mind-blowing conclusion in modern cosmology. There was first the discovery that the universe is expanding outward in every direction of space because of the red shifted light coming from distant galaxies, and then theoretical considerations from general relativity also reinforce that idea, showing that the universe, the material universe itself, had a definite beginning. Even time and space began. If there's an infinitely tight curvature of space, that suggests that there's no place to put any matter, and so we have a fundamental challenge to the materialistic worldview, or the worldview of scientific materialism. Now, beginning in the 1980s, late 80s, Stephen Hawking and other theoretical physicists, Hawking, who was involved in the 1968 proof of the singularity theorem, didn't like that conclusion too much, began to think of some other alternative explanations. And Hawking came up with something called quantum cosmology, which he popularized in a book called The Brief History of Time, which he published in 1988. I was a PhD student at Cambridge at the time, and actually attended the series of lectures that Hawking gave that became the little book, The Brief History of Time. Anyway, since the late 80s, there's been this idea that the laws of physics by themselves can explain the origin of the universe from literally nothing. And that therefore there's no need for any kind of external agent or creator, no transcendent cause of any kind. That the laws of physics alone explain where the universe came from. So whereas in the early 80s, there were books coming out like God and the Astronomers by Robert Jastrow, and other major figures in astronomy were saying, hey, look, this Big Bang theory, this singularity theorem clearly has theistic implications. It's pointing to the need for a cause that transcends matter, space, time, and energy. Who does that sound like? But after the 1980s, this quantum cosmology idea has caught on and has seemed to kind of neutralize the implications of the Big Bang, at least with respect to being affirmative of theistic belief. In fact, many of the new atheists have taken up quantum cosmology as their go-to explanation for how you get a universe without God, one of those being Lawrence Krauss. Now, I've gotten more into quantum cosmology in the last couple of years, and it turns out there are a couple of reasons to doubt that this idea of invoking the laws of physics, the laws of quantum physics, can explain where the universe came from in the first place. The first is that this whole research program misunderstands what laws do. Laws don't explain where matter and energy come from. Laws describe how matter and energy interact once they exist. They don't give you an origins explanation. They describe the ongoing behavior of the entities within the universe.
That's kind of the same thing that we talked about last week with the guy with the energy thing, right? The first law of thermodynamics. Well, the laws only apply after the universe is created. So you can't like invoke the laws to create the universe because the laws don't apply until after the universe is already created. Does that make sense? So that's why, like Hawking said, if there is the law of quantum gravity, then we can get a universe. Well, you don't have a law of quantum gravity if there's no universe, right? Because there's nothing. There's no time, there's no space, there's no energy, there's no matter. So where's gravity fit into that, right? And again, the laws are just describing what's there. They don't cause anything. They're just describing, if I drop this, I could work out equations like in physics class to tell you like how fast it drops and wind resistance and all that stuff, and use the law of gravity to explain it. But the law just explains what happens. The law didn't make that happen, right? Does that make sense?
So that's a fundamental philosophical problem. Secondly, a law of physics is expressed mathematically as an equation. And those equations exist in the minds of mathematicians and physicists. They don't actually exist in nature. Our laws describe the behavior of material entities and energy and so forth, but they don't in any way cause things to happen in the material world. So to say that the laws of quantum mechanics cause the universe to come into existence is a strange kind of category error. It's like saying the latitude and longitude lines on a map are responsible for the rise of the Himalayan mountains. The map describes where the mountain is, but it doesn't tell you how the mountain got here. Now, there's one final problem, and this is the one that I think is most profound. The quantum cosmological model wants to describe our universe as a reasonably probable outcome of something called a quantum mechanical wave function. It's often represented with the Greek letter psi. So psi is a function that describes all the possible gravitational fields that could be instantiated or exemplified by our universe. Gravity, in Einstein's view, is curved space as a result of the concentration of matter. So this universal wave function describes all the different configurations of matter and all the different shapes of space that the universe could have. And it becomes an origins explanation when that wave function includes our universe as one of the reasonably probable outcomes of all those possibilities. But here's the problem that I discovered. In order to get a quantum mechanical wave function, you have to solve a prior quantum mechanical equation, something that's analogous to the Schrodinger equation in ordinary quantum mechanics. But the physicists themselves tell us that you can't solve that equation unless you apply a number of what are called boundary constraints, which are limitations on the mathematical degrees of freedom expressed in that equation. Or another way to put it is
you have to put the limits in there.
The equation is insoluble without the imposition of boundary constraints. But who imposes the boundary constraints? Who restricts the degrees of mathematical freedom, the possibilities that could exist? Well, it's the theoretical physicist. Now, anytime, and this is basic information theory, anytime we say we exclude one option and elect another, we're imparting a bit of information. So if there are an infinite number of solutions to this prior equation, and that's what the physicists tell us, then you have to supply a huge number of boundary constraints to make the equation soluble. And that means you have to supply a huge amount of information. And in the mathematical modeling of the origin of the universe, who supplies that information? The theoretical physicist, the intelligent agent. So even in cosmology, it now appears that there's an information problem. An information problem that's only solved in our modeling by an intelligent agent choosing some boundary restrictions, boundary constraints, and limiting the mathematical degrees of freedom in various ways to generate a wave function that includes our universe as a reasonably probable outcome. So you've got multiple problems with this quantum cosmology, but the deepest one is that it's actually modeling the need for information to give you a finely tuned universe.
All right, there will be a quiz on that later.
Well, the fine-tuned...
Stop.
tuning of the law
Ah.
and
All right,
the constants of physics and the initial conditions, that is the arrangement of matter at the
there. All right. So the bottom line is in all this, next week I want to deal with we'll do kind of the same thing, but I'll show you a video about a guy who's objecting to this and then a response to it.
Is it gonna be
Next
the-
week?
Oh, yes, I am, you're right.
Is it gonna be
2
the
weeks
thin
from now.
line?
No, that guy has videos on this if you want to watch, look that up yourself. There's one, he does one about the puddle argument, and there's a back and forth with him and another guy.
Oh, wow.
But it's sort of the same thing. It's like the way that he rephrases things and misinterprets things and stuff. It's like we
I
kind of
don't
we
think
did
he
that already.
misinterprets it. I think he purposely misinterprets
Well, he does purposely.
Obviously.
All right, so we'll wrap it up there. We'll close our time and work. So again, we just thank you that you reveal yourself through your creation, Lord, that we can even just by looking at what you have created in this world, that it points back to you, Lord, the designer of all these things. We thank you that you decided to create us. We thank you that you knew what we would do, that we would rebel against you, and yet you allowed us to be here, knowing that in order to redeem us back, it would necessitate the death of the Lord Jesus Christ. We thank you that he came and died for us, and that he rose again. We thank you that he's coming back for us, and we look forward to his soon return. We just pray you would help us as we think about these things, to be a good witness and testimony for you. In Jesus' name we pray. All right, we'll see you, Brandon.